Hello, doctor. Hello, everyone. I will introduce chromatography and its application in the field of biological science. This is my name and metric. I will introduce from three parts: introduction, types of chromatography, HPLC, CCC, in the biological application, and bioanalysis conclusion. Firstly, I will introduction the chromatography. Chromatography is the separation of analytes from a complicated mixture of similar constituents for quantitative and or quantitative identification, which is applied to both organic and inorganic compounds. Compounds are separated from a mixture by passing them through a stationary phase use the mobile phase carrier. Chromatography is commonly used technique in clinical laboratories for diagnosing inborn carbohydrates, protein, and lipid metabolism errors. There are many chromatography that are suitable for bioanalysis. Liquid chromatography, particularly in high-performance liquid chromatography. This is a high sensitive and efficient technique among different chromatography techniques. High pressure ensure high resolution and better separation of closely related to components such as protein separation, nucleic acid analysis, gas chromatography, inert gases like nitrogen, helium, or argon, or low-mass gas such as hydrogen are used in mobile phase to separate volatile compounds or substances that can become volatile after derivation. GC estimates lipids, drugs, and vitamins. Countercurrent chromatography. Firstly, I will present the application of high-performance liquid chromatography in biological field. The stationary containing proteins and phospholipids, such as AIM. This is immobilized artificial membrane that can mimic the biological environment where drug molecules distribute. The applied mobile phases aqueous organic with a pH of 7.4 to imitate psychological conditions that could be encountered in human body. The chromatographic system mimics the in vivo partition process from Figure 1. So we can Figure 2. Through this, using the new biomimetic stationary phase to predict drug-induced phospholipidosis. By mobilizing various phospholipids on a cyclic stationary phase, providing an intermediate step between in cyclic and more complex in vitro assays. Although the AM retention selectivity and the derived binding data show similarity to octanol water partition, they found that positively charged compounds partition more strongly to the AM phase than to the octagonal phase, which is more similar to compound partition to the biological membranes. And secondly, I will present countercurrent chromatography. Chromatography is a liquid chromatography technique in which one of a pair immiscible liquid is placed in the tubular structure and moved in planetary motion. Polyethylene, glycol, and potassium phosphates are often used aqueous two-phase system in CCC for isolation and purification of macromolecules and protein. This is known as hydrodynamic force tends to cause emulsification of these two aqueous phases, but that's hydrostatic force provide a clean separation of protein. DNA and tRNA have also been purified using CCC. This is a schematic view of liquid motion in CCC column. A is hydrostatic column or CCPS. They are a single axis of rotation producing constantly centrifugal field and no phase exchanges in the connecting ducts. B is a hydrodynamic column. They are variable cyclic centrifugal field produced by the planetary rotation of bobbing around its own axis and the central rotaxle. This is contact between the two liquid phases through the tubing. The mobile phase is pictured in black. The stationary is white. Finally, I will introducing bioanalysis. Bioanalysis involves a broad range of chemical analysis. The analysis include biotics such as drugs and their metabolites in biological system, as well as biotics such as drugs and their metabolites in biological systems, because many biotics and cyanobiotics are not volatile molecules. The main technique for bioanalysis is high-performance liquid chromatography, and the limitation of GC utilization is caused by the fact that GC is applicable only to one natal samples. However, GC chromatography coupled with mass spectrometry as detection is also very useful technique in bioanalysis. In conclusion, there are many types of chromatography, like high-performance liquid chromatography, current chromatography, and gas chromatography are employed in biological research, which can be used separation and analysis of macromolecule, predicting the drug-induced phospholipidosis biotics. This method enables researchers to study the structural function and interactions of biomolecules such as proteins, nucleic acids, and carbohydrates. Applications including proteins purification, gene cloning, forensic analysis, and biomedical research, contributing significantly to our understanding of biological processes and the development of new treatments for diseases. This is my reference list. Thank you for your listening.